Most people are using Codex like a slightly more capable chatbot. They open a thread, type one instructions, watch it work, then type another instruction. This is useful, but it's not the autonomous coding agent people imagine. When they hear that Codex can run tasks, coordinate agents, work across apps, and continue while they're away from their computer. The interesting capabilities are already here, you just need to combine the right ones. In this video, I'm going to show you how to get Codex to continue working toward a measurable goal, run recurring tasks automatically, use multiple agents for larger jobs, keeps parallel code changes isolated, continue from your phone or a remote environment. Connect to the tools you already use and operate websites and desktop applications for you. We're going to build these up in 4 stages. First, we will make Codex continue until the job is actually complete. Then we will improve the quality of larger tasks by combining reasoning, persistent planning, sub-agents, and worktrees. After that, we will get Codex away from our desk using cloud mode or mobile remote control. And finally, we will let it work across plugins, connected apps, Chrome, the in-app browser, and the desktop application. Let us begin with that feature that stops Codex from declaring victory a little too early. A normal Codex prompt represents one turn. You describe the task, Codex works on it, and eventually it decides that it has completed enough to give you an answer. For smaller tasks, that's fine. But for a migration, a large research project, a complicated bug, or anything requiring repeated checking and improvement, I think I'm finished is not a strong enough completion condition. This is where Codex goals come in. A goal gives Codex a durable objective and a verifiable stopping condition. Instead of asking it to vaguely improve something, we tell it exactly what finished work must contain and what evidence allows it to stop. I have prepared a folder called O1 Goal. Inside it are 2 files. The first one is videobrief.md. This contains the target audience, the promise of the video, and a required structure, the tone, and several constraints. The second one is my research notes. This contains deliberately messy notes. Some claims are correct, some are questionable, and some are explicitly marked for verification. Now I'm going to open O1 Goal project in Codex, start new local thread, briefly open video brief, and research notes. Now I'm going to give Codex a real stopping condition. I'm going to type /goal, build a complete YouTube planning package for videobrief.md and researchnotes.md. Do not stop until final video package.md exists and contains exactly these 5 top-level sections. Audience promise, 5 title options, structured video outline, demonstration checklist, and claim audit. The claim audit must label every factual product claim as verified. The key part is not simply the /command, the key part is the contract. Codex knows the name of the app file, the 5 sections it must contain, and how factual claims must be labeled, which files is allowed to read, which files it must preserve, and exact conditions that it must be true before it finishes. Notice that I have not asked Codex to work forever. I've told it exactly what evidence allows it to stop. This is the difference between an open-ended instruction and an autonomous workflow that can be verified. While a goal is active, you can inspect its status, pause it, resume it, and clear it. If /goal does not appear in your /command menu, the goal feature may need to be enabled in your Codex configuration and settings section. For Codex to work independently, it needs enough permissions to complete the task, but that does not mean giving it unrestricted access for everything. Codex uses permission profiles and sandbox boundaries. A workspace level profile can let Codex read and edit the current project while preventing it from wandering through unrelated folders. Actions outside those boundaries can still require approval. The sensible setup is to give Codex the smallest boundary that still allows it to finish. If it only needs the current project, give it access to the current project. Do not use unrestricted access as your default just because it removes a few clicks. Convenience is lovely, accidentally reorganizing your digital life at 2 in the morning is less lovely. By the way, if your task is too complicated, remember when you're using the goal, write how many tries it can use. For example, it can use 100 tries and you will run out of tokens. So remember to mention that. And now, as you can see, it has provided us the final video package with title options, structured video outline, demonstration, checklists. As you can see, it's a complicated task, so the /goal becomes very handy with these types of tasks. A goal handles the definition of done, and automation handles when the work should begin. For this demonstration, I've prepared a realistic content blocking inside the O2 automation folder. The plain source is content backlog.csv. It contains video ideas, production status, priority, owner, due date, audience demand score, estimated hours, and blockers. I've also included a formatted workbook called Content Planning Demo, so the same information is easier to understand on the screen. Before scheduling anything, we should test the automation prompt manually. The instructions live in automation prompt.md. They tell Codex to read the CSV and create weekly content brief containing an executive summary, overdue items, and 3 highest priorities, blocked work, a recommended next video, and data quality warnings. Testing the prompt first matters because a scheduled task will repeat whatever ambiguity you give it. Once the manual result looks correct, I can create the automation directly from a regular Codex thread. I'm choosing a standalone project automation because each weekly report should be an independent run. If I want a Codex to wake up inside the same continuing conversation, I would use a thread automation instead. So here's our automation results. I created the automation 3 weeks ago, so it has created 3 content brief.md files for me in the past 3 weeks. And also there's an option on the Codex to make your Mac or make your computer always stay on. So because of security reasons, I didn't leave it on, and try to be careful with it. When an automation runs, its findings appear in the triage and the project receives a new weekly content brief report. There's one important limitation. Because this is a local automation, my computer must be awake, the project must remain available on disk, and Codex must be running. This is background automation. I mostly run Codex on my computer, so I have no problem with it. Autonomy is not particularly useful if the results becomes worse as the job becomes bigger, larger. Long tasks usually run into 2 problems. First, the main conversation fills up with research notes, command outputs, failed tests, screenshots, and logs. Second, the task may require more analysis that you would use for a simple file edit. Codex gives us several ways to address this: reasoning effort, persistent plans, sub-agents, and worktrees. Codex supports the different reasoning effort levels. Lower efforts is useful when the task is straightforward and speed matters. Medium is a balanced default. Higher effort is useful when Codex needs to trace complicated logic, compare alternatives, and check assumptions, or investigate edge cases. Higher effort generally means more time, more tokens, so do not use maximum settings to rename a button. For this example, I've prepared messy lunch brief.md inside planning reasoning folder. It describes a possible paid mini course, but it contains contradiction. The intended audience is beginners, while the current lessons assume technical knowledge. The proposed recording schedule is shorter than the work itself. The price is undecided, and the definition of success is also unclear. I'm not asking Codex to execute the lunch yet. I'm asking it to create a persistent source of truth inside the project. This gives the workflow an external source of truth. Even if the conversation becomes long, Codex can return to project plan, recover the original constraints, and see what remains unfinished. The plan is where the strategy lives, and the chat is where the work happens. So here's the prompt that we used. Read messy lunch briefing.md file. Do not execute the launch. Create a project plan MD as the persistent source of truth. It must contain the objective audience, constraints, assumptions, unresolved questions, and all of it. And the important part is keep the plan practical enough that other agent could execute it without reading that chat. So if you had a data that is messy and the agent, there's a chance that it could not complete it and leave the work in the middle and give you the results. The planning mode is very practical. Sometimes one agent should not do everything sequentially. Codex can spawn specialized subagents and run independent work in parallel. Each subagent receives a bounded assignment and returns a distilled results to the main agent. For demonstrations, I've created O4 subagents folder, contains 2 datasets. Audience comments CSV file contains 15 realistic viewer comments with comments, ideas, topics, engagement, sentiment, and viewer level. Competitor snapshot CSV contains 8 competing video angles, their promises, observed viewer response, and gaps. Now I'm going to explicitly ask Codex for 3 different specialists. So here's the prompt that we use. Use 3 subagents in parallel and wait for all 3 before continuing. And it describes the agent's tasks, agent 1, agent 2, agent 3. After all agents finish, synthesize their work into subagent receive reports.md, include an executive summary, separate findings from each agent, a rank list of 5 recommended videos, evidence, ideas, and a final section called What We Still Do Not Know. Do not modify the CSV inputs. The first agent is focused entirely on audience demand. The second is looking for competitive gaps. And the third one is not generating more ideas. Its job is to challenge unsupported conclusions and improve the quality of the synthesis. The main agent then combines those results into one report containing evidence, ideas, and clear sections explaining what the data still cannot tell us. This keeps noisy exploration away from primary thread and lets several read-heavy tasks to happen simultaneously. Codex does not automatically spawn subagents simply because the task looks difficult. You should explicitly request parallel agents when they would help. They are especially useful for research, codebase exploration, test analysis, security and maintainability reviews, and comparing implementation approaches and processing large groups of documents. Be more careful when several agents are editing the same file. Parallel thinking is wonderful. Parallel editing of the same paragraph is a tiny office dispute waiting to happen. For parallel code changes, Codex has another useful feature, Worktrees. A worktree gives a Codex thread an isolated checkout of a Git repository. That means one thread can build a feature while another investigates a bug without both agents changing your main working directory. Inside O5 Worktrees, I've prepared a small Git repository called Side Project. It is a simple static landing page with one HTML file and one CSS file. The original headline says build your next video with less chaos. Now I will ask Codex to change the page inside the isolated worktree. Okay, for demonstration, you're going to open a new project, choose the directory that your repository is there, which is the site project here. And then instead of local, you're going to choose the worktree. You know, there's local, there is a cloud, and also a worktree. And then we're going to paste our prompt here that says to add 3 cards and change the CTA, do some CTA, and don't change the README file. And here's our results. As you can see, it has changed the CTA, it has added 3 cards, but the important part is, now I can switch back to the original local project. The worktree contains the experiment, while the main checkout remains untouched until I deliberately bring the work back. Use local mode when you want Codex editing the current project directly. Use worktree mode when you want an isolated experiment or several coding tasks running side by side. And also use cloud mode when you want the task to run in your configured remote environment. Once Codex can work toward a goal and handle larger tasks, you do not necessarily need to sit there watching it. There are 2 different ways to take Codex away from your main computer, and it's important not to confuse them. A cloud thread runs remotely in configured cloud environment. This is the cleanest option when the task does not depend on your files or application that exists on your laptop. The second option is mobile remote control. Codex can connect to the GPT mobile app on your phone. Now let's talk about the cloud remote control. This environment still needs the correct repository, dependencies, secrets, and network configuration. The advantage is that my personal computer is no longer doing the work. If cloud is not configured for your account or repository, show the mode selector, explain the equipment, and do not pretend that local thread is running remotely. From your phone, you can start a thread, continue an existing one, or send follow-up instructions, approve actions, inspect diffs, and test results, review screenshots, and receive a notification when Codex finishes or needs your attention. This is especially useful when a task depends on local computer, its files, installed plugins, and sign-in applications. But there's an important distinction. Mobile control reaches this host, it does not turn the host into cloud infrastructure. If this computer sleeps, disconnects, or closes Codex, remote access stops. For genuine continual local access, you can use a dedicated always-on Mac or Windows computer, or connect Codex to a remote machine over SSH. So these three choices are straightforward. Use cloud mode for remotely hosted work, use mobile control for reach an existing Codex host, and use an always-on or SSH host when you need a persistent access to a specific achievement. So far, Codex can continue working, run on a schedule, coordinate agents, isolate code changes, and operate remotely. The final step is giving it access to a tool where your work actually happens. Codex plugins can bundle reusable skills, app integration, and MCP servers. If you have a Google Drive connected, I can make a safe read-only request such as use Google Drive to find the folder named Codex demo sources, list its files and summarize their titles only, do not edit or move or share or delete anything. A dedicated integration is usually preferable to clicking through an application visually because it's faster, more structured, and easier to verify. Well, now as you can see, Codex has used the MCP, Google Drive MCP, and found the Codex demo sources and listed files and titles only. And here's our files and titles, and it says it did not edit, open, share, or delete anything. Now this is my Google Drive, and here you can see the Codex demo sources for Google Drive, and this is our sources, and they match the same stuff the Codex gave us. If Codex does not have a ready-made integration for a tool, it can connect through Model Context Protocol or MCP. MCP Server gives Codex additional tools and external context. That could be a design tool, an internal knowledge base, or documentation service, or database, browser tool, or a custom system your company built. The clean distinction is this: a plugin is a package workflow that may contain skills, app integration, and MCP servers. An app connection gives you structured access to a service such as Gmail or Google Drive. An MCP server is a lower level way to provide external tools and context. You do not need MCP for every workflow, but it's the escape hatch that makes Codex extensible beyond the integration supplied by default. Now, some jobs require a real browser where you all already signed in. For that, Codex has a Chrome extension. It can use your authenticated browser state to work with sites such as Gmail, Salesforce, LinkedIn, YouTube Studio, or internal business tools. For this demonstration, I'm using a read-only task in this website. Before recording, I've already installed the Chrome plugin connected to Codex extension, signed into the demonstration website, hidden private information, and decided which usernames need to be blurred. Okay, now as you can see, it has opened using Chrome extension, the OpenAI's logging page, and did all the tasks that we gave it. And the first impression, the page feels clean, trustworthy, and message clarity, visual hierarchy, and mobile risks, accessibility risks, and top 5 fixes. The add outcome copy, manage API keys, project, user village. So it's a good tool to just analyze, especially for web developers, to just analyze the UI of the whatever website that they're trying to use, they're trying to create. Chrome is for signed-in browser state, for local host file-backed previews and public pages that do not require your normal browser profile. In the app browser is usually the better choice. I can demonstrate that using the same static site prepared for the Worktrees section. Now I can ask Codex to inspect the actual rendered interface rather than reasoning only from the HTML or CSS. This gives us a tile build and verify loop. Inspect the rendered page, make a small change, and then visually check the results again. So first I asked Codex to start a simplest available local static server and opens this HTML file in its own browser. And then I'm gonna use this prompt to review this page and improve only accessibility and small screen readability, preserve the copy and overall visual direction, verify the page again after editing to summarize the visible changes. We're gonna paste it here and don't forget to use browser mode. So this is our final results. The hero headline keeps the same large bold feel but now has normal letter spacing. On mobile, the hero is less vertically stretched and the CTA keeps the same look, not with the 44 pixel minimum touch target. And the benefits panel is a little tighter. So finally, Codex computer use can operate supported graphical desktop applications. It can see applications, click controls, type, navigate between windows, and follow workflows that do not have useful API or plugin. For the demonstration, I've deliberately using a calculator rather than a sensitive application. The result is visually obvious, and the task cannot publish content, send a message, or alter an account. This is intentionally a simple task because it makes the capability easy to see without creating unnecessary risk. Computer use is a fallback for graphical workflow. If a structured plugin exists, this is usually faster and easier to verify. But computer use becomes valuable for older enterprise software, desktop testing, application settings, and workflows spanning several graphical tools without a useful API because it can affect real applications and accounts, keep scope narrow, and remain present for sensitive operations involving payments, passwords, security setting, publishing, or private information. So before using computer use, it's going to ask us to allow it to use computer use from settings, and as you can see, it's used the calculator app. It did it so quickly because it's a simple task, and the answer is correct. So make sure you know the security vulnerabilities when you use the computer use or browser extension. Let us put everything together. Imagine I want Codex to produce a weekly YouTube opportunity report. I keep the source backlog in a project file. I create an automation that runs every Monday. The automation follows a durable prompt that defines exactly what the report must contain. If the job grows larger, I ask several sub-agents to analyze audience demand, competitive gaps, and unsupported claims independently. A goal defines a required output and prevents the workflow from stopping before the report contains its required sections and evidence. If part of the workflow changes files or website, I can run that work inside an isolated work tree. The final report appears in my Codex triage box. If Codex needs my attention, I can receive a notification and response from my phone. If the task can run in a configured remote environment, I can use cloud mode instead of depending on my laptop. If the workflow needs information from a connected service, it can use a plugin or app integration. If it needs a sign-in website that has no structured integrations, it can use Chrome with the permissions and restrictions I choose. If it's reviewing a local website, I can use the in-app browser. And if the only available interface is the desktop application, computer use can operate the graphical workflow within the scope I define. That is a very different experience from sitting at your desk and entering one prime at a time. Codex becomes less like a chat window and more like a collection of workers, schedules, tools, isolated environments, and verification loops that can assemble around a real outcome. The key is not turning on every feature at once. Start with one repeatable task, give it a clear definition of done, then decide whether it needs a schedule, a persistent plan, parallel agents, a work tree, an integration, browser access, or remote environment. Once that first workflow is reliable, build the next one. And if this video was helpful, like, subscribe, I really appreciate it. That's a big help. And in the comment section, tell me which part of your work you would most like Codex to handle while you're away. Tell me about that. See you in the next one.